Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Good morning everybody. Okay, ada request nak discuss on trust. Okay, welcome to my channel. Okay, today this morning cuaca pun elok. Kita online sekejap untuk discuss on indeterminate trust when the redundant is come from member force. Okay, I have picked one question from previous exam paper. I'm not sure which year is this. Okay, let's look at the truss. Okay, this is a plain pin jointed truss. Pin at A and supported on roller at C. It is subjected to a point load, horizontal load and vertical load. Cross-sectional area 150 mm square and modulus of elasticity 210 kN per mm square for each member. Question A. By removing a suitable redundant, develop the flexibility relation for the truss. Question B. Identify the support reactions and solve the axial forces in the truss member. Okay. Step number 1. To analyze this, we have to identify how many redundant in the system. And for truss, we have to calculate the degree of indeterminacy by using this formula, where M is equivalent to members, R is reaction, J is joint. So for this truss, we have okay, this truss has one member. How many members? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 members. Reaction, because of one pin, one roller, the truss has 3 unknown reaction. Join, we have A, B, C, D and E, so we have 5 joint. So the degree of indeterminacy is equivalent to 1. Okay, as I mentioned in class, truss has 2 types of indeterminacy. Okay, it can be indeterminacy in truss. Okay, it can be externally free. It can be externally indeterminate. Externally means the redundant is come from reaction. This is because reaction can be calculated. The reaction at the support can be calculated using all external loading that is subjected into the truss. Okay, number 2, in truss, another one is called as internally indeterminate. It means that the redundant in internally indeterminate truss is come from member force. Because member force is internal forces, so we call the indeterminate truss when redundant is member force. So we can call the trust as internally indeterminate. And number 3 is combination. Combination of externally and internally means redundant in the system. There are 2 redundant. One is come from reaction, one is come from member force. So for externally indeterminate, redundant from reaction. For internally indeterminate, redundant from member force. And for combination, redundant. Normally for combination, when redundant is more than one. So redundant 1 and redundant 2. Maybe redundant 1 come from member force or reaction. And redundant 2 come from member force. Okay, this is basically the indeterminacy in trust. Okay, so back to this trust. Remember that in indeterminate trust, the minimum unknown reaction is 3. By looking at this trust, there are 3 unknown reaction which is come from support. Means that in this case we have calculated degree of indeterminacy for this trust, and we found that degree of indeterminacy representing redundant in this trust is 1, and we have to check the reaction at the support. If reaction is equivalent to 3, means the redundant is not from the reaction, because it has reached the minimum reaction in the trust. So now there are 3 unknown reaction. We cannot remove one reaction from these 3, because if the trust has 2 reaction, the trust is not stable. The trust is not determinate trust. Okay, means that in this case the trust is actually internally indeterminate trust. Means the redundant is come from member force. Okay, so in this case they are redundant from member. So normally we will remove either the member inside this rectangular, inside this. Okay, we can remove either member BE or member CD. Take out from the trust. Okay, let's say okay, this is the trust. Okay, we have to remain all the support reaction because it is now determinate trust due to the support. So okay, from the question, removing a suitable redundant means the redundant is not given. You are free to choose any members as redundant. Normally for trust like this, we will remove either member BE or member CD. Okay, let's say we remain like this. Okay, this trust is now primary trust. Okay, we have removed member CD. This is A, B, C, D and E. Okay, 200 and 150. Okay, this is now primary trust. Okay, so in this case redundant is F force in member CD. Okay, this is the trust. So for having this as the redundant, okay, we can write the compatibility equation for this one. Okay, remember that this is force, so we are determining delta 1 naught plus F11, because there are two system, one redundant, two system. The displacement in primary system is delta 1 naught, and the displacement in redundant system is F11. Okay, F11 is actually delta 11, and delta 11 is equal to F11 times with redundant times with FCD, and this is equal to 0. 0 means there is no deflection, okay, in actual thrust. Okay, from this we know that there are two displacements to be determined, which come from two system, primary system and redundant system. Okay, so this is the primary system. This is primary thrust, where we will determine later after this and not. Okay, and another one is redundant, is called as redundant FCD applied. Okay, remember for redundant thrust we will have to analyze the same redundant with same support, with the same support, the same redundant with the same support, but this time the thrust is now subjected to a unit value of redundant. So in this case, this is redundant FCD applied. Okay, since FCD is member force, we have removed member CD in primary thrust. So if for redundant thrust, we have to apply a unit value, a positive value of FCD like this. Okay, we have to apply positive. This is positive, right? A unit value. This represent positive, right? Positive value of member force. A unit value of member CD. A unit value of force in member CD. So this is 1 times FCD. Like this. This is for this is when the redundant is member force. Means that we have the system just like the primary system. What is the difference between primary system and redundant system is due to loading. The primary system is stable and determinate, which is to all external loading. And in primary thrust, we will determine the member forces and not. Okay, for redundant thrust, in this case, when the redundant is member force, we have to have the same type of primary thrust, but this time the thrust is now subjected to a unit value of member CD, a unit value of force in member CD. So we apply into the system like what I did right just now, like this. Okay, since this is internal forces, please remember, we calculate reaction due to external loading. When there is no external loading, there is no reaction value. And in this case, there is no external loading. Inside the truss is internal force. A unit value that we apply into the truss is internal force, not external force. So the reaction for this truss is 0. This is 0, 0, 0, because there is no external load. Okay, so by having this truss, what we need to do is we have to use easy method to determine N1. Okay, so for this case, okay, recall back, we have discussed in class last week. So for determining the member force using easy method, we will choose we can start at joint with one triangle. Okay, so for this case, at member, so this is A, B, C, D and E. Okay, so having like this, straight away, okay, because we need to balance horizontally and vertically. Okay, the truss must be externally equilibrium. It must also internally equilibrium. Okay, if we check for external equilibrium, when there is no external loading, means there is no reaction. So, and after that we have to check the internal loading. Internal loading means we have to balance each joint. At each joint, we have to make sure that total Fy is equal to 0, total Fx is equal to 0. Okay, now from this, okay, if we do not clear, just do like this. 0 nak balance dengan 0, so automatic this is 0, this is also 0. So what next? Next is by looking at this, okay, this box B, C, E, D. Okay, we have to play with the arrow first. Okay, do like this. Okay, by having knowledge about vector, okay, this resultant force, when we resolve, we can resolve in X and in Y, like this, because a unit value is the resultant force. So the resultant force can be resolved in X and Y. So we do for both, like this. Okay, we put the value later, we just have to balance the arrow first. Okay, so after this, remember that for member, okay, at C, we have to balance the arrow, the horizontal arrow, like this, and the vertical arrow, satu going up, another one must be going down, like this. Okay, so complete the member force, So we do the same for joint D. Balance with this one, okay, like this, and D vertical value, vertical arrow going down, there must be going up like this. Okay, balance with this. Okay, now at joint B, this arrow must be balanced, means that kalau satu ke kanan, mesti ada satu ke kiri. Kalau satu ke bawah, mesti ada satu ke atas. So like this, you must do this one and this one. Okay, So for joint E, satu ke kanan, satu lagi mesti ke kiri. Like this. Satu ke atas, satu lagi mesti ke bawah. Like this. And we get another resultant force for member BE like this. Okay, basically for truss, when the member force is redundant, we just have to do like this. Okay, other than outside this box, the value is all zero. The reaction is zero. Force in member AB is zero. Force in member AD is zero. Okay, so now is the time to put the value. What is the horizontal value? What is the vertical value? Okay, we go back to question. And by using trigonometry. Okay, we found that this is the triangle. The vertical length and the horizontal length is the same. 4 meter, 4 meter. Means the ratio is 1 to 1. Okay, if like this, 4 square plus 4 square square root, so it is 5.657 meter. So we do interpolation to get the horizontal value and the vertical value. So it is 4 divided by 5.657. It is equal to 0.7071. So now we have determined that the value is both is vertical value and horizontal value is the same, because the angle is the same, the ratio is 1 to 1. So this is 0.7071. This is also 0.7071. 0.7071. This is also 0.7071. Okay, like this. Okay. Alright. So what we need to do now, okay, after we determine all the member forces in both system, the member force in primary system and the member force in the redundant system, we have N0 and N1. We have to put all the value in the table. Okay, this is the example where the external forces is given in the system. There is a case when the truss has no external force in the system, but the truss may have other effect which come from temperature changes or fabrication error. Okay, so to determine FCD, the redundant value, we have to determine delta 1 naught, means deflection in primary truss, and F11 deflection in redundant truss. Okay, basically in primary truss, in real situation, deflection in primary truss or deflection in real truss, okay, can be determined due to 3 conditions. Okay, condition number 1, due to external loading, N1 and not L over AE. And not, we determine N not from external loading. Okay, if the truss has the effect of temperature, we have to consider the temperature changes in the system. So for temperature changes, N1 is remain. Okay, N1 is remain, the redundant is remain. Okay, formula for this is alpha delta T L plus N1. Okay, N1, the N1 is remain. Okay, and if there is fabrication error, we have to consider as well, like this. Okay, but for this question, there is no effect of temperature changes and fabrication error. When there is no effect of temperature changes and fabrication error, delta T is equal to 0, delta L is equal to 0. So we only consider external loading. This is external loading, right? This is due to external loading. Okay, however, when the effect of temperature and fabrication error need to be counted, we have to consider all together to determine the deflection in primary truss. For redundant truss, this is just as usual, N1 square L over AE. Okay, we need to consider the effect of temperature as well as fabrication error in primary system. Okay, then that's all. Okay, we determine N0, we determine N1, we put into the table. Okay, we find the summation of N1 times N0 times L. We find the summation of N1 times N1 times N1 times L, N1 square L. So we get delta 1 naught value, we get F11 value. Then we just have to substitute into the compatibility equation. Okay, just substitute into the compatibility equation. Then we get F CD is equal to the redundant value. Okay, so the answer is not final yet because this is just the redundant value. So we need to continue to determine the remaining reaction using superposition method. Okay, using superposition method, we have to determine AY, AX, and what? And CY. And CY in superposition method. Because superposition method is easier compared to equilibrium equation. Superposition method. So AY in primary truss plus AY in redundant truss times redundant FCD. To determine AX, we have AX in primary truss plus we have AX in redundant truss times FCD. And after that, for CY, we have CY in primary truss. We also have CY in redundant truss times with FCD. And finally, we have to determine the member forces. Determine member forces in actual truss. Means that we have to determine one by one value. for each member. Okay, the member forces in actual truss, let's say, is N, and N is equal to we just have to write the formula. N is equal to the member forces in primary truss is N naught plus the member forces in redundant truss is N1 times with redundant FCD. So basically for this one, we have to make table again. Member, we have N not come from primary truss, and 1 come from redundant truss. So N is member forces in actual truss, and this is N naught plus N1 times FCD. So we have just to list all back. CD, C, CE, right? B, A, B, B, C, C, E, and so on lah. CE, DE, and so on. All 8 members. In actual truss. Okay, so then it is the end of analysis of indeterminate truss using flexibility method. Okay, I just go through again. So support reaction is reaction AY, AX and CY. Axial forces in member is N. Alright, so we have to analyze this indeterminate truss. The truss is internally indeterminate because from the truss we know that there are 3 unknown reaction. It is now stable in terms of reaction, but the redundant is now come from member force. We have to remove the suitable redundant member from the system. So I choose to remove member CD from the system. So we have like this. This is the primary. This is the primary truss. Okay, from primary truss, we need to determine N naught. Okay, and this is for redundant truss. Remember that for redundant truss, it is the truss, the determinate truss subjected to a unit value of FCD, and FCD is member force, means internal force. There is no external force in the truss, means there is no reaction in redundant truss. So what we need to do is we have to apply a unit value of FCD like this, and then after that we have to use easy method to balance all the error, and after that we use interpolation, trigonometry and interpolation to determine the horizontal value and vertical value, like what I have shown to you just now. After that, this is N1. So after that, as usual, we have to summarize all values into the table. We determine the summation of N1 N naught L, N1 square L, so we get delta 1 naught and F11. We have to substitute into the compatibility equation, and by solving the compatibility equation we will determine FCD. After we have determined redundant, it is not the end of analysis. Okay, anyway, read the question carefully. Normally the question will ask us to finish the analysis. However, if the question doesn't ask you to do that, so don't do that. But for the purpose of practicing this, please continue to calculate the reaction as well as member forces. Finish the analysis. Okay, so we can determine the reaction, the remaining reaction and the member forces in actual truss. We are using superposition method like this. Okay, for reaction, we have 3 unknown reaction: AY, DY, AY, AX and CY. So we apply the principle of superposition. Okay, same goes to member forces. Member forces, we have determined N naught and N1, which come from a real primary system and redundant system. So remember that in redundant system, it is actually FCD inside the truss. However, we take out FCD, we put like 1 times FCD, means everything inside the system must times back with FCD, like this. So N means member forces in actual truss equal to N naught member forces in primary truss plus N1 times FCD. N1 is member force in redundant truss. So the final answer is like this. We have to list all the member forces in actual truss. Okay, so we have N0, we have N1. So we show that we have to show all the values for N member forces in actual truss like this. Okay, remember to put all the members, to list all the members. Original members is 8, including redundant. We have to put all in the table. Okay, that's all for today. I hope this will help you to do other trust question. Basically, it is the same. Okay, Assalamualaikum. That's all. Assalamualaikum and good luck.